Hey, I've been told to cheer you up before lunchtime, which we're going to run late, by the way, so hope you have a lot of cookies and everything else to keep you going. Right. Namaskar. My name is Alicja Gilderdale, and I am an engineer by profession, by degree, and definitely by heart. Technologies, especially automation, being part of my whole life, and I've been very fortunate to work in a company which allows me to implement all of the technologies and my passion into work. I'm here to talk about containers orchestration. It's a subject which was rapidly evolving for the last 3 years. And I think Swapnil and Sunil were warming him up with quite lots of deep dive tech information. So I'm really happy because I don't have any deep dive here. So you're going to see loads of pretty pictures. Okay, so container orchestration become a part of my current project. And it's quite a priority to create a future-proof digital infrastructure in the project. The day I've been announced as a speaker, the day after, I went for a walk with my husband and my dog, Snoopy. He's much slimmer now, been on a diet. And both of them were very, very excited for me. And my husband asked, so what are you going to present? And I said, well, I'm going to talk about container orchestration. And I gave him this agenda. And he was like, oh, okay, that's a little bit confusing because your title is what's in the box. So what's in the container? I was like, you're not going to talk about the containers? I'm like, no, don't be silly. Everyone knows what the container is. So I'm going to skip to the right things, and I'm going to talk about the containers. It's like, be aware you may miss half of your audience here, and you become irrelevant for about 45 minutes. So I didn't expect that, especially 2 months before, and I was quite angry, and I gave both my husband and my dog silent treatment till the end of the day. But what he did manage to do was like plant a little thought in my head, which next day I woke up and I'm thinking, okay, why don't I just give a chance to my audience to decide whether to cover some basics and say, okay, what's the containers, what's the little history about it? So I'm going to ask you if by any chance today, you really feel like nurtured by nature and you really don't want to think about what is the container and hear this very short, exciting, and very colorful story about where it all began, can you raise the hand? Wow, okay, we have a really good audience today. Thank you. That means that 2 weeks of my work is actually going to work now. Okay, so let's start from the containers. I put those slides to give a little bit of comparison of what we used to have or what we still have and what we're actually trying to get to or we're already implementing in many projects. So as you can see, the container is the operating system level virtualization. It's kind of multiple hosts, isolated user spaces, instances. It allows you to use the same application binaries across different environments. So from your development to production, you can deploy exactly the same image. So you can deploy them on your laptop, you can deploy them on your server, in your cloud, wherever you want to. And the one fact is that any Unix, Linux-based containers can be deployed on any instance which is Unix, Linux, or macOS based. any Windows-based container can be deployed into the Windows operating system. Also, currently, IBM announced their IBM Cloud Private, which basically allows you to create your own containers and compile it to be x86, Z series, mainframe, power compatible. So it allows you to give you much faster functionality of the containers of those particular systems. Okay, so just deep down a little bit more into the what actually is in a container. So it's a lightweight, standalone, executable package. And it's kind of a piece of software which includes everything in order to run it. So it's code, runtime, system tools, system libraries, and settings. Right. That's the pretty picture of my... So that seemed to be jumping too fast, because I wanted to ask you, what do you think was the very first concept of containers, where actually it become the reality in technologies? And the very first operating system, which was mainframe, was I think in 1956. And the very first concept of containers started in 1979 with Unix version 7. So 38 years ago, right? I wonder, when did you find out about containers? Right, so Unix version 7 introduced a chroot system call, and that was changing the root directory of the running process and its children to a different location on a file system. And this concept was a starting point to introduce process isolation, like segregating file access for each process. Then, quite 2 decades later, in the year 2000, free BSD jails been developed to achieve like a clear-cut separation between services. And jails had the capability of assigning IP address to each system and configuration. Then we had a few more, which was Linux vServer, Oracle Solaris containers in 2004, and in 2006 it was the process container launched by Google. And it was designed for limiting and isolating resources like CPU, disk I/O, network, memory, and later on it's been renamed to control groups, C groups, and then been merged into Linux version 2624. Again, we got a few more LXC Linux containers, Warden, Cloud Foundry, and we're running into year 2013, my favorite, LMCTFY. Let me contain that for you. That's awesome. So again, it's the open source version, Google containers. And the same year, it was a very exciting year, 2013, and containers exploded in popularity by introducing Docker. And what Docker separated itself from all of the group was introducing the ecosystem of container management. And the same year, in February, CoreOS introduced Rocket, RKT, and it was treated like a competitor to Docker. Well, we'll see how it goes. As a consequence, after year 2013, there was this natural need of having the container orchestration to fulfill the requirement of managing and scaling all of the sets of container infrastructure. So in 2014, there was a Marathon framework introduced by, powered by Apache Mesos. Then in 2015, Kubernetes by Google. And Kubernetes been then given to Cloud Native Computer Foundation in 2016. And 2016, Swarm mode. So there was a Docker Swarm in 2014, but later on that wasn't integrated within the Docker engine. And in 2016, they introduced that as a completely integrated, out-of-the-box Docker engine, and they renamed it Swarm mode. I'm going to talk about those things later on in a little bit more details anyway. So, and at the end, without the dates, because that's like this year and a little bit of last year, we have Amazon ECS, Container Services, GKE, Google Container Engine with K, container, and Amazon Container Services. So all of those are cloud-based container providers. Okay, so why I'm here, right? What's my story? So I'm working on a project which been quite fortunate. It's a 2-year project now, and we were fortunate to work from that from scratch, and we didn't have any monolith applications, and we didn't really need to work on any migration. So it was really easygoing 14 microservices project, which connecting to external system through the messaging service. And it's worth to mention that all of the teams, so development and operations, started at the same time. So we had like this equal start to create infrastructure and develop the code. And from the beginning, we had quite a lot of challenges due to our infrastructure being hosted on premises provided by the third party. And we did have kind of platform that we can request self-service instance, but unfortunately, it was still a manual job. You have to go on a website and you have to just request the instance and so on. So, and I'm sure that quite a lot of people probably nod here and say, yeah, it's so normal. So we very quickly realized that with very rapidly developing code, we can't really be in a position where we request the instance and developers get it their own, and we kill it, we recreate it, and so on. We didn't have that luxury to do it. So we had to create this multi-environment instances where developers shared their own, well, the one VM across, let's say, 2 or 3 environments. And to enable the code deployment, build, test, deployment, we have very good developers, and they are very proactive. And they were proposing that, you know what, I'm going to spin it up in my own container, and I'm going to run it on my own local machine, and then we'll see how it goes. I create my own Docker Compose file, which will nicely put that together and orchestrate it and understand my dependencies, and spin it up temporary on our virtual machines. So that was great. Off my shoulders, I'm great. Yeah, here you go, there's a VM, you spin it up. There's some continuous integration in Jenkins that's basically allowed to do it. But from operability perspective, it was absolutely scaring, because I'm thinking, oh gosh, we have the Docker Compose, but how is that going to prepare us to the production environment where we need to think about scalability, security, networking, balancing, self-discovery, and you name it. So yeah, there were quite, well, a few sleepless nights. And that's where we came up with the idea, okay, why don't we just try one of the orchestration container orchestration and just see how it goes and what are the functionalities and whether it is actually production ready or not. So before I jump into the details of each of the main providers, I think it's worth to say that each of those container orchestration frameworks do the job and have quite a lot of common features. And I picked up 7. I don't know, I like number 7, but and it was quite good on the page as well. So I'm going to cover the main common features that probably everyone would be concerned about in going into production. And let's start from provisioning. Okay, so all of them can provision or schedule containers within the cluster. And these tools can determine right placement for the containers by selecting an appropriate host and based on specified constraints like resources or location affinity. And there's an example here that I maybe have a pointer. Like node 1 has prod and blue as tags, and depending what we deploy, if the tag matches that set of three labels, that will be a node to choose from. So the underlying goal for provisioning is to increase utilization of the available resources. And most tools will be agnostic. And in theory, you should just take those containers, move to another cloud provider or any other provider, and just spin it up. Yeah, in theory. The second one will be configuration as code. And my colleagues in the previous session, they did show a little bit of code in their demo. So it's all based on the blueprint. It's like a schema written in YAML and JSON file. And defining blueprint in this manner makes it easy for DevOps teams to edit, to share, to version the configuration, and to just create the repeatable deployment process across every single environment. So third one is the monitoring. You've probably seen this one from Kubernetes from the previous session as well. So they track the health check of the containers, and if the container crashes, it just spin it up. And if the host crashes, it will just bring the new one and deploy containers onto it. So it's quite nice self-healing. And monitoring will show you most of those activities as well. Oops. So service discovery. So since containers are based on microservices architecture, service become a critical discovery become a critical function, and it's provided in different ways by different providers. This is an example from Kubernetes. So it's based mostly on DNS or proxy, and it works the way that if the web, let's say, application front end dynamically will discover any new microservice or any new database instance. Then we have scalability. So it can be scaled manually, or for some providers, it can be scaled automatically. Like for Kubernetes, it can be scaled on CPU usage. So if you run out of this particular layer of CPU, it will just spin up another instance for it. And the networking. I'm not going to talk about a lot of networking because it's quite a complex subject, and I have loads to cover. But basically, it isolates each of those orchestrations can isolate independent containers, can connect coupled containers, and can also allow access from the external client. There's loads and loads of articles on the internet how each of them do it, and it's really, as I said, it's very complex. It's quite an completely separate subject. So Load balancing. So I think that's the last one, number 7, lucky 7, okay. So it works with conjunction of well, container replication, scaling, service discovery, and load balancing can be a dedicated service that knows which replicas are running and provides an endpoint that exposes the clients using different methods such as DNS round robin. For example, in Swarm, all nodes anticipate in an ingress routing mesh as well. Okay, so I think I covered the basics. I know it's quite heavy now. I'm going to be back to my story. Okay. So while planning the path into production, our client decided to go with AWS. So that was given. Yeah, no problem, VPC. We have our VPC. We have our beautiful, clean VPC. Now let's decide which container orchestration we're going to use. And so we were very ambitious, and we came up with a plan of creating a massive table with every single feature possible, with every single container orchestration on the planet. And that's supposed to pick up the gold one, like the best from the best, right? So after this exercise, we were so confused that we kind of had to revert the tactic and say, okay, I think that there's no way we can just say there is one standout and we're going to go with it. We need to look at it from what actually the project needs. What do we require from those container orchestration? Because there's so many features, but you're not going to use all of it. You know, we have 14 services, microservices. So we decided to gather a little bit list. Say, so what's important for us as a project? Well, okay, we're going to deploy Docker containers. Great, so no more, there's no monolithics, there's no additional convoluted configuration that we really need to go. We have a bootspring Java files within the container. It's very much by standard microservice developed into the container. So we also want to use Docker Compose file, because if those guys used all their efforts to deploy to development in their own personal environments using Docker Compose, why then I need to spend all that time translating it into something different? And that means that I would need to depend myself onto any changes that appear into Docker Compose files. So that was quite an important factor to enable us to move across every single environment, no matter how small or big it is, and just use Docker Compose files. Our client is very much focused on security, so we had to make sure that we have a really inside-out security and all of the TLS certificates in place. And the most importantly, and I'm not sure whether you guys thought about it before, or I think it's a little bit underappreciated. Well, client had to agree on the tool, which is, you know, you think, okay, we'll pick up this one or that one, but yeah, somebody has to support it, and somebody has to say, yeah, I'm kind of familiar with the orchestration itself, so we're comfortable with it. So we couldn't be very bold with our statement and just say, let's go do something new, because we already were introducing something new into the whole program. We were actually a pathfinders to the program with containers, and you know, having the whole approval that we can use them was a massive jump for us and massive success. So we had to go with something very stable, very known to the public, and that was, I think that was one of the deciding factors, really. So, okay. So let's go now and see what big fish in the sea we have, and what choices did we have. Okay, talking about the sea. So Kubernetes, probably the largest one from the usability perspective. Lots of people use it, and well, Google recognized potential of Docker image quite early, actually, and they released it in February 2015 with the goals and considerations in place. So that's the diagram. Yeah, I love those diagrams. I'm not sure whether you guys see it. Okay, so the application can be deployed in the combination of pods, deployments, and services. So I think that guys were talking about pods in the previous session, but it's a set of co-located containers, and it's the very basic unit of the deployment. So you can't just pick up container from the pod. If you define it as a particular theme, let's say you're monitoring, then if it goes down, or if it is being deployed, it's being deployed in one go as well. So there was a quite good factor for it for Kubernetes. It's the auto-scaling. So as I mentioned before, you can do the you can define, like, if it reaches particular levels of my CPU usage, just spin up another one. Auto-scaling is great, especially for the companies where, let's say, betting companies, where you have to be very reactive over how much of the, how big is your infrastructure and how small is your infrastructure at some times. And I think it can save so much money. Okay, so Kubernetes didn't use Docker Compose straight away. They have a tool that transforms Docker Compose. So it's a little bit, it's not so straightforward, but there is a tool called Compose with K, and that allows you to take the Docker Compose file and just transform it to the Kubernetes style configuration. Also, Kubernetes have quite interesting feature, which is the 2 levels of health checks. And first one is liveness, which is like, is my app responsive? And the other one is readiness. So is my app responsive, but still busy and not accepting any incoming calls? There's also, Kubernetes also have the basic logging mechanism. So it takes the all aggregated logs from the pod, which is really, really useful as well. And I think it's coming as an add-on anyway, so you do need to install an add-on to have the logging functionality. And the networking model is flat, and it enables all the pods to communicate with each other. Also, we have a DNS server available as an add-on. So from version 1.6, Kubernetes can scale up to 5,000 nodes per one cluster, so that's quite a lot. And you have modular API, which allows to integrate system around the core Kubernetes. So quite a lot of vendors can hop on and just create their own code to integrate. And also, what's quite flexible from from Kubernetes is that you can deploy Docker and Rocket on it. Okay, so breaking news. Well, not so breaking, because it was last month in October, DockerCon. Docker announced that they're going to integrate Kubernetes into their enterprise edition. So what does that mean for Swarm, right? Are they going to ditch it? No. Well, so they committed to do both, and they say that they're going to support both. They want to expand their ability to cover Kubernetes and Swarm. Well, a good choice, I guess. Yeah, let's move on to these lovely whales. So Swarm mode, because now it is called Swarm mode. It's not Docker Swarm anymore. So well, Docker Swarm, as I mentioned, was 2014. Swarm mode is 2016. So when you deploy your Docker engine, you get this for free. Great. Couple of comments, and you have your clustered environment in place. So it's very easy. It's all in one. We love all in ones, right? And it's quite complex underneath, but it doesn't feel like it. It uses Docker API and all of the Docker familiar commands, so it's really good. And you can use Docker Compose straight away. It will basically, if you have one instance and spin up your Docker Compose, you can also do that on distributed nodes. It will take exactly the same Docker Compose file, and it will nicely distribute across the nodes with the DNS mesh. So it's quite interesting one, very easy. Health checks, it's only limited to the services, so it's just only on the services level. And one restriction, it can only run Docker. So yeah, surprise, surprise. Right, so from the Docker blog post, they proudly say that that you can deploy up to 1,000 nodes and up to 30,000 of containers in one cluster. So that's quite a number, but it's still clustered as a small deployment. So yeah, so I think that's there's a little bit of choice of how many containers you can use. And autoscale is not directly available, but AWS supports some of that functionality with Docker, with the swarm mode. Okay, I'm going to move to Mesos and Marathon. That's heavy now. I know, it's lunchtime. Sorry, guys. Right, so, well, Mesos is really a cluster manager. It's not the container orchestration. And it allows you to take, so if you do have quite complex project where you need to migrate from monolith application, or you run something like a big data or real-time analytics, you really could consider Mesos and Marathon as your option. Like Twitter, Apple or Yelp, Uber, Netflix, all of them actually use Mesos with Marathon. So, and this is coupled for the last 7 years, so it's quite bulletproof. They swear they're very much production ready, and for any heavyweights, I think that's it's quite an attractive couple. Okay, so that was the biggest pieces for those 3 big providers, and I'm going to talk about those beautiful pictures. So we're having the cloud-based container services providers, Amazon, Google, and Azure. So if the whole point of containers is the portability, right? And cloud-based container services are not portable. Does that make them a bad idea? Well, for many projects, the opportunity to more easily launch and scale containers farms overweighs the portability limitations. And container services can be set up for various workloads, and in a fraction of time, you really have very well done orchestration in place. So, of course, you kind of think, okay, but that locks me down to that provider. I really don't like that. Well, just ask Netflix how they're dealing with this. So, so yes, if cross-platform portability is very, very important for you, then probably this is not a choice for you. But if you do have the application where you just really want to focus on the code and you want to be just get on with your application and don't really have heavyweight DevOps infrastructure team, then probably one of those choices could be a good option. Okay, so I'm going to come back. That's the 3rd one, so we're almost finishing here. Okay, so from all of those facts and everything, again, it's only 14 microservices in our infrastructure. So we really, and as I mentioned, we had to restrict ourselves to big names and something that our client will know and accept. So we had to really narrow down this to Kubernetes and to Swarm. We sat down, we ran a demo on AWS, and we came up with quite a few findings, which was quite interesting. So I'm going to start from Kubernetes. Well, it does require a little bit of configuration setup, and there are quite a lot of supporting repositories with the modules and images that you can pull from the internet, and it gives you amazing flexibility of the functions, but 10. Oh, you throw me out. So if you have any problems with your internet, like any restrictions about your internet, like my project is a government project and it's not that easy to get into internet and that, you run into probably quite an issue, because now you don't have access to internet and you have to have all those modules to even start your configuration. Well, yeah, you have to make all of that effort to maybe filter down the modules that you really want and download them, put them into your own local registry, and here you go. But that does make a little bit of effort. It's worth in the long run. So from the Kubernetes side, well, I did mention about Docker Compose, that we really wanted to have a Docker Compose as it goes, and we don't really need to fiddle about changing it or do anything from our side. So that was like one downside of it. Good side was, well, it has the UI. So you have those beautiful pictures, you can look at it, and yeah, it's useful. Definitely it's useful. From Swarm, so there was absolutely, it took no time to spin up Swarm for us. It's, we got the Docker engine, we got the Swarm, we could basically run a couple of commands and that's it. Well, yeah, we didn't have a UI and you had to provide an additional tool to enable you, but they are available and they are absolutely great. Yes, Docker Compose, so again, Docker Compose direct. Yes, no worries, developer is taking care of it. If it's a problem, come back to developer and being checked against. So Docker Swarm has an internal DNS mesh, as I mentioned, and it resolves links defined inside Docker Compose. I'm not sure how many people are familiar with Docker Compose, but it's quite nice. It's quite nice concept. So if you do then spread it across the multiple nodes, you actually you sustain those names and everything. So you don't really worry about how your microservices connect to each other, because you still have exactly those links. And one more thing with Docker EE being quite active this year, you know, if we want to go from the community edition to the enterprise edition, we have a lot of security checks, which are really nice security gateways that stop you if you don't want to. Well, if you get your container with any vulnerability, it will check it automatically in the registry, and it will say, no, you can't deploy it because it's not secure. You have to get it back. So it's quite useful. Yeah, so the downside of Swarm mode is, well, okay, we don't have a massive framework to play with. So if you do want to do something custom, you'll be struggling a little bit. So if you do have a simple microservices, that's a perfect solution for you. Okay. How many of you have seen this picture? Like probably every single presentation about Docker is with this picture. But yeah, it's quite true. So just the decision making, like if you do have a small project, I didn't tell you which one we chose, but I think that it's quite obvious what we went for. I'll bet. So yes, it's just the small projects. Yeah, Swarm is quite good. You will have no overheads. It's quite easy to spin up. You're happy. Medium projects, go with Kubernetes or Swarm as well, and decide upon your own list what you actually want to achieve from the framework. Because having too much in your framework is not good. You are. And if you do have, if you do have to migrate something, or you have your still big applications that you have to work with, then again, Mesos may be a great solution for you. And I think that Mesos also these days allowed to use Kubernetes instead of Marathon. So here you go, another good news. So yeah, it looks like Docker and Mesos, quite a few start using Kubernetes these days. Favorites. Okay, so, and if you don't want to worry about your infrastructure, then go with something which is cloud-based. Why not? Be bold. I think it's worth it. I didn't mention about so many other beautiful container orchestrations. I looked into Container, and it looked really interesting. But I do strongly encourage you guys to basically read about it and see, maybe there's something that you want to experiment with. It's always worth it. Those will be constantly developing, will be constantly expanding with the new names, and it's just worth to keep it in mind that we're not only strict ourselves to the main 3 big bosses. Right, and I think I'm going to wrap it up. Whew, I'm on time. Okay, so whatever you choose, right, you already have done a great job, because you start thinking about it as you want to move into this new world. And containers are the fact. It's nothing new. 38 years old, I think it's quite proven by the need. And you're just embracing all of this. The tools which are efficient, which are easy to spin, which are supporting development work, DevOps work, and I think you can't go wrong with any of them. You just need to see what is the most suitable for the direction you want to go. Yes, and I think on that note, Dhanyavad. Okay, got it right. Thank you. Okay. Do we have any questions? Or you probably want to go for lunch, don't you? Yeah? Oh, hungry people. Great, I love it.
All right, thanks, Alicia.
Thank you.
All right, fun fact, everyone, about Alicia. Is this audible? Yeah. So when Alicia decided to talk about containers, she didn't know she's going to travel all the way to India to do it. So yeah, but we're really happy to have you here. All right, so this ends one of the presentations. So the next presentation would be after lunch. So I'll see you guys around 2:30. Yeah.